This was our computer at the end of the last video. We have added the network card underneath the motherboard, but there were two more pieces of work still required. Firstly, we will update the BIOS on the Odroid H3 Plus to support the new card, and secondly, we will complete the work on the frame to allow us to mount it in its new rack. The first step is to download the correct BIOS for your Odroid. In this case, I am updating an H3 Plus Odroid using the H3 B1.17 release. On screen are the locations from where you can download both the H4 and H3 BIOS updates. Once you have unzipped the BIOS to a USB drive, you're ready to boot your computer up with the USB drive attached. This will display a list of attached devices from the device mapping table. Enter in FS0: into the shell, or FS1 or 2 if that's what you have. As we're going to be using the BIOS for the network card, we type in fbnet.nsh and press enter. This will start the BIOS update. We'll speed through to the end of this process. Now that the BIOS update has completed, we can power off the Odroid, remove the USB drive, and do a clean power up to have a look at our changed BIOS. The project version is now showing as H3 1.17. If we look at the Advanced tab of the BIOS, we will see that it's reporting 2 Realtek Ethernet ports and 4 Intel ports. So the BIOS is now correctly identifying the new network card. The next step is to install Windows on this computer, which I'll speed through. Once Windows is installed, you may well need to install drivers for the new ports. If you check your device manager and see that there are a number of devices highlighted, you'll need to download a number of files. The o2.chipset and 05.gna driver zip files are probably recommended. Run the chipset one first. You may also need the Pro 2500 zip file too. These can be downloaded from Odroid's website shown here. Once the device manager is showing no further issues, then you are good to proceed. Now, before we test out the new network card, we'll complete the second part of this video on the case and rack. And we're also going to be making some changes to the frame of our computer. I've added a small heatsink to the top of the power supply. The power supply was getting slightly warm, not uncomfortably so, but a heatsink on the top will take care of that quite nicely, allowing the power supply unit here to be completely passive. Also, we have no fascia in the front of our computer case, and we have still to add our power switch. So I have cut out a piece of polypropylene, spray painted it with black Plastidip, and this is going to become our fascia, which will slide quite nicely into the maker beam. Like so. And we will just close up the frame by adding on our end piece. And that is the frame complete, with our fascia in place. Now we need to add one of the power switches. These are supplied ready-made up from Odroid itself. We can just feed this through the front of our fascia, and we'll put the locking nut into place. And we'll just hand tighten this. And that is our power switch. in position. All we need to do is to route our cables so we can plug these into the GPIO header. Which is located down here on the edge of the board. Now, as you'll see on screen, the wiring for the H3 board is slightly different to that of the H4. The pins themselves are exactly the same, but the location of the GPIO header is slightly different on the H3 board than it is on the H4 board. So you need to take care to make sure you're using the right cables in the right place. So we'll take our black cable and locate it in here. Our red cable goes into pin 4. Which is this one. And we have a green cable in number 17. And a blue, the final one, in pin 19. With all these in place, that's our cabling done. We just have to do a little tidying up of our cables and we're ready to go. The structure of the computer is now complete. The only thing that will be needed to add to the bottom of our case are some silicon rubber feet. So here is our frame with a couple of 3D printed brackets mounted in a 10.5-inch rack frame. You can see that I've run an Ethernet cable from an Odroid H4 Plus computer down to the second port of the new network card. One of the Realtek Ethernet ports is connected to the hub my main computer is attached to. We can use this setup to compare the time it takes to copy files from one computer to another. So we are remote connected to Odroid 13, which is the one with the new network card. And we're going to copy a 1 GB video file from Odroid 13 to Odroid 12, which is connected to the new network card, and also to the Octal 2 computer. Odroid 12 will be using a 2.5 gigabit per second connection, and Octal 2 will be using a 1 gigabit per second connection. Both of these computers will be writing to M.2 SSDs. So if we copy to Octal 2 first, by just dragging the file across. As we can see, the average rate of transfer is about 113 megabytes per second. So next we will copy the same file, but this time to Odroid 12, utilising the new, faster network card. This time, the transfer speed peaks at 273 megabytes per second. So we can see that despite the 4 new Ethernet ports having only one PCIe lane each, we still manage a transfer speed 2.4 times faster than the 1 gigabit per second connection. Obviously, this is only a single file transfer on a single port and falls short of full network utilisation. But this new computer will be part of a forthcoming cluster processing project connecting to 4 H2 Odroids on the Power Basic for Beginners YouTube channel. That's it for today. Thank you for watching.